greedy algorithm, right? In that, we learn basics of greedy approach. What is the difference between greedy method and dynamic programming, right? Then we discuss the make a change problem using the greedy method, right? From that example, we can easily understand the difference between greedy uh, method and dynamic programming method, right? So next topic in greedy algorithm is minimum spanning tree, right? Minimum spanning tree is also a one type of problem which we can solve, right, using the greedy approach, right? There are two algorithms, right, for generating a minimum spanning tree using greedy approach. One is Prim's algorithm and second one is Kruskal's algorithm, right? So before uh, we understand those two algorithms, right, let us first understand what is spanning tree and what is minimum spanning tree, right? So take G equals to n comma n. G is a graph, right? G is a connected and undirected graph where capital N is the set of nodes and A is the set of edges, right? All of you clear with the graph theory? Right? Graph theory is already part of your data structure subject. Right, so all of you clear with the node, what is nodes, what is edges, or
Yes,
should
ma'am.
I? Okay,
Yes, ma'am.
okay, right. So let G is a graph, right? But G is connected and undirected graph, right? Now each edge has given positive length or weight, right? Each edge in G contains some weight, right? But positive weight, right? Now next is spanning tree, right? So what is a spanning tree? A spanning tree of a graph G is a subgraph which is basically a tree, and it contains all the vertices of G containing no cycle or no circuit, right? It means a spanning tree is a subgraph of graph G, right, which is basically a tree, right, and it contains all the vertices of G but without any cycle, right? So this is the spanning tree. Next definition is minimum spanning tree, right? So minimum spanning tree of a weighted connected graph G is a spanning tree with minimum or smallest weight, right? Spanning tree is a one subgraph of G which does not contain any cycle, right? Now what is minimum spanning tree? Minimum spanning tree is a spanning tree of a graph G with minimum or smallest weight of edges, right? So this is the definition of spanning tree and minimum spanning tree. And weight of the tree is, the weight of the tree is defined as the sum of weights of all its edges, right? Now, as I said earlier, there are two algorithms, right, which are used for constructing a minimum spanning tree. First one is Kruskal's algorithm, and second one is Prim's algorithm. Right. Now let us understand the spanning tree with the example. Right. Consider this as a graph G. Right. It has this many nodes A, B, C, D, E, F, G, H, and number of vertices. Right. Now if you want to generate spanning tree from this graph, right, then you can derive spanning tree like this, right? It contains all the edges of G, sorry, all the vertices of G, right, but does not contain any cycle, right? So it contain all the vertices A, B, C, D, E, F, G, H, right, but does not contain any cycle, right? So this is the spanning tree for this given graph G, right? Another example, right? So this is the spanning tree for this graph G, right? Now let's start with the Kruskal algorithm. Before that, uh, let's discuss the application of spanning tree, right? So there are two main application of spanning tree. First one is spanning trees are very important in designing efficient routing algorithms. And whenever you want to design routing algorithms, right, in networking, right, then at the time spanning trees are very important. Second is spanning trees have wide application in many areas such as network design, right? So in networking, spanning trees are very important for different networking application, right? So let us understand first the Kruskal algorithm, then we understand the Prim's algorithm, right? So Kruskal algorithm, right? Kruskal algorithm is the algorithm of obtaining minimum spanning tree, right? In this algorithm, always a minimum cost edge has to be selected, right? But it is not necessary that selected optimum edge is adjacent, right? So in Kruskal algorithm, we always select the minimum cost edge, right, to derive the spanning tree, because the aim of the Kruskal algorithm is largely derive the spanning tree with minimum weight, right? So let us understand the Kruskal algorithm with this example, right? So all of you draw this graph in your notebook with its weight, right? All of you draw this graph in your notebook with its weight. Right? So in Kruskal's algorithm, first we will select all the vertices, right? Then the edge with optimum weight is selected from the heap, right? It means the edge with minimum weight is selected from the heap even though it is not adjacent to previously selected edge, right? But we have to take care of that. If we select this edge, then it will not form the cycle, right? So select edge such a way it has the minimum weight, right? And if you select this edge to create a spanning tree, right, then it will not form the circuit, right? So first in this graph, tell me which edge has the minimum weight or optimum weight. A, B, B, C, C, D,
CD.
B.
C, D, right? So taking minimum edge CD, right? Now after CD, which edge has minimum weight? Because in Kruskal algorithm we select the edge with optimum weight, right? And it is not compulsory that uh, selected edge is adjacent to previously selected edge, right? So we can select any edge which has minimum weight, right? So first we select CD, then Next
BC.
is BC, right? Taking next minimum age is BC, right? Then next is BE, right? Next, taking next minimum age is BE, right? Because BE has weight 3, right? Now next is AB, right? Because AB has weight 4, right? Then next AE, right? Next age is AE because AE has weight 5. But if we select AE, right, then it will create a cycle. So we cannot select AE to create a minimum spanning tree. Right? ખબર પડી બધાને why we can't select the age AE? Though AE has the minimum weight among the remaining ages, right? But if we select the AE to create a spanning tree, it will create a cycle here. Right? So we cannot select the age AE. Getting?
Yes, ma'am.
Right? Next is CE. Right? CE has a weight 5. Right? But if we select CE, then this will also create a circuit. Right? So we cannot select the age CE. Right? Next is AC. If we select AC, then this will also create a cycle. Then next is AD. If we select AD, then this will also create a cycle. Then next is DE. So if we select the DE, then this will also create a cycle, right? Then we completed with all the ages. We cover all the ages of the graph. No remaining age in your graph, right? So this is the final spanning tree for this given graph, right? With no cycle, right? Now, so we obtain a minimum spanning tree of cost 4 plus 2 plus 1 plus 3, that is 10, right? So 10 is the weight of this spanning tree, right? And this weight is minimum, right, for creating this spanning tree. So it is known as we can call as minimum spanning tree. Getting all of you how to create a minimum spanning tree using Kruskal's algorithm,
Yes, ma'am.
right? So in exam they will provide you one graph, right? You have to write down like this. Step 1, select this age, then draw that age. Then step 2, select this age, then draw that age, and at the end write down minimum spanning tree of cost is equals to this, right? So this is the Kruskal's algorithm. Now let us understand the algorithm step, right? Function Kruskal g is equals to n comma a, where n is a node of graph and a is a ages of graph g, right? Sort a by increasing length, right? So we have to sort the all the ages in increasing length or weight, right? And small n is equals to number of nodes in n. If your graph contains 10 nodes, then value of small n is equals to 10, right? T is equals to 5 ages of the minimum spanning tree, right? So total number of age that we select for creating a spanning tree, that will be the value of t, right? Initially it is null. Now define n sets containing a different element of set n, right? Then e is equals to u comma v, where e is the shortest edge not yet considered, right? Initially. Then find u, right? Find u and find v, right? If ucom not equals to vcom, then merge ucom and vcom, right? This find u tells us in which connected component a node u is found, right? It means this node is for the final minimum spanning tree, right? And this merge ucomp and vcomp is used to merge two connected components, right? If you find any node u, right, then T union E. So this edge is now added into spanning tree, right, until T contains n minus 1 edges and return value of T. Right, let us understand this algorithm with the use of example. So consider this graph, right? Now first step is sort the edges in increasing order of their weight, right? So write down all the edges, that is 1 comma 2, 2 comma 3, 4 comma 5, 6 comma 7, right, like this, and write down all the edges of this graph into increasing order of their weight, right, like this. Then step number 2 is select the minimum weight edge but no cycle, right? So first 1 comma 2 is selected, right? Then next minimum weight edge is 2 comma 3, so that is selected, because if we select 2 comma 3, then it will not create a cycle, right? The next is we have two edge with same weight 3, right? 4 comma 5 and 6 comma 7, right? So if we select 4 comma 5, right, then it will not create cycle, so we can select 4 comma 5, right? Next is 6 comma 7. If we select 6 comma 7, then also it will not create a cycle, so we can select 6 comma 7, right? The next is we have three edges with same weight 4, right? So if we select 1 comma 4, then it will not create a cycle, so we can select 1 comma 4, then 2 comma 5. So if we select 2 comma 5 here, right, so it will create a cycle here, so we cannot select 2 comma 5, right? Next is 4 comma 7, right? So if we select 4 comma 7, then there is no cycle, so we can select 4 comma 7, right? Then next is 3 comma 5, right? So if we select 3 comma 5 here, so it will create a cycle, right? Right, so we cannot select 3 comma 5. Then 2 comma 4, so if we select 2 comma 4 here, then it will create a cycle, so we cannot select 2 comma 4. Then 3 comma 6, same, it will create a cycle, right? So we cannot select 3 comma 6. Then 5 comma 7, again it will create a cycle, and 5 comma 6, again it will create a cycle, right? So final, the minimum spanning tree for the given graph is like this, with edges 1 comma 2, 2 comma 3, 4 comma 5, 6 comma 7, 1 comma 4, 4 comma 7, right? And add all these edges weight, right? This will give you cost of this minimum spanning tree, and that is 17, right? So all of you clear with this Kruskal's algorithm,
Yes, ma'am.
Yes, ma'am.
right? Now next algorithm which is used to generate a minimum spanning tree is Prim's algorithm, right? Now what is the difference between Prim's algorithm and Kruskal's algorithm, right? So in Kruskal's algorithm, right, obtaining a minimum spanning uh, uh, right, in procedure of obtaining a minimum spanning tree, right, it is not necessary to choose adjacent vertices of already selected vertices, right? We can select any edge with minimum weight, right? It is not necessary that we have to select the next edge which is adjacent to previously selected vertices, right? But in Prim's algorithm, for obtaining minimum spanning tree, right, we have to select the adjacent vertices of already selected vertices, right? We have to compulsory select the adjacent vertices of already selected vertices, right? So let us understand the Prim's algorithm in detail, right? In Prim's algorithm, the minimum spanning tree grows in a natural way starting from an arbitrary root, right? In Kruskal algorithm, we select first edge who having the minimum weight in given graph G, right? But in Prim's algorithm, you can arbitrarily select any node as a root of the spanning tree, right? So next is, at each stage we add a new branch to the tree already constructed, right? The algorithm stops when all the nodes have been reached, right? As I said, we have to select the next vertices, right, with adjacent what who is adjacent to already selected vertices, right? And the complexity of the Prim's algorithm is theta n square, where n is the total number of nodes in the graph G, right? So let us understand the Prim's algorithm with the use of this graph, right? So you can draw this graph in your notebook, right, and solve this graph using Prim's algorithm, right? So this is the graph, right, and we want to generate a minimum spanning tree for this graph using the Prim's algorithm, right? So if we use the Kruskal algorithm, right, then first we select which edge with minimum weight, right? But in Prim's algorithm, select an arbitrary node, not the edge, right? In Prim's algorithm, select an arbitrary node, not the minimum weight edge, right? So in Prim's algorithm, right, first node we select is 1, right? Then find an edge with minimum weight which is adjacent to 1, right? So there are two edges which is adjacent to 1. One is 1 comma 2 and second is 1 comma 4, right? Here there are two edges which is adjacent to vertex 1, that is 1 comma 2 and 1 comma 4, right? Now in these two adjacent edges, which is minimum, which have the minimum weight? 1 comma 2, right? So cancel 1 comma 4 and select 1 comma 2 as is the edge for the spanning tree, right? Then next node set is 1 comma 2, right? Next node set is 1 comma 2. Now write down all the adjacent edges of 1 comma 2, right? So that is 1 comma 4, 2 comma 3, right here. 1 comma 4, right? 1 comma 2 is already included in this spanning tree, so no need to consider this, right? So 1 comma 4, 2 comma 3, right? 2 comma 4 and 2 comma 5, right? All the adjacent edges from the vertices 1 comma 2, right? Now from all these adjacent vertices which have the minimum weight? 1 comma 4, 2 comma 4, 2 comma 3 and 2 comma 5, which have the minimum weight? 2 comma 3, right? So cancel remaining edges, right, and select 2 comma 3 as a edge for spanning tree, right? Now next node set is 1 comma 2 comma 3, right? Now write down all the adjacent edges of 1 comma 2 comma 3, right? But do not write the edges which we already included in the spanning tree, right? So 1 comma 4, 2 comma 4, 2 comma 5, then 3 comma 5 and 3 comma 6, right? 1 comma 4, 2 comma 4, 2 comma 5, 3 comma 5 and 3 comma 6, right? Now select the minimum weight edge, right? So which edge has minimum weight? 1 comma 4, that is 4, 2 comma 4, that is 6, right? 2 comma 5, 4, 3 comma 5, 5 and 3 comma 6, 6. Which age has the minimum weight?
1,4 or 2,5.
Right? 1 comma 4 or 2 comma 5. Right? Now why they don't select the 2 comma 5? Right? Because, right, we have two options, right? Either we can select 1 comma 4 or either we can select 2 comma 5, right? But that selection is depends on the programmer, right? So here select 1 comma 4, right? Either you can select 2 comma 5 also, right? But here we select the 1 comma 4, right? Now next node set is 1 comma 2 comma 3 comma 4, right? Now write down all the adjacent edges, right? That is uh 2 comma 4, right? 2 comma 5, 3 comma 5, 3 comma 6, then 4 comma 5 and 4 comma 7, right? Now which one has the minimum weight? 4 comma 5, right? So select this edge as the edge of spanning tree. Then next adjacent node, sorry, next node set is 1 comma 2 comma 3 comma 4 comma 5, right? Write down all the adjacent edges, right, and find the minimum weight edge, that is 4 comma 7, right? Here if you select the 2 comma 4, then it will create a cycle, so you cannot select the 2 comma 4. Then 2 comma 5, again it will create a cycle, so you cannot select the 2 comma 5. Then 3 comma 5, again it will create a cycle, so you cannot select 3 comma 5, right? Then 3 comma 6, right? And 4 comma 7, 5 comma 7, right? So among these three, 4 comma 7 has the minimum weight, so select the 4 comma 7, right? Then again next node set is 1 comma 2 comma 3 comma 4 comma 5 comma 7, right? Write down all the adjacent edges and select the edge which does not create any cycle and have the minimum weight, right? So select 6 comma 7, right? So this will be the vertices for your spanning tree with cost 17, right? So the minimum spanning tree for the given graph, right, with total cost 17 is like this, right? So this is the Prim's algorithm, right? Let us understand the Prim's algorithm, right? You can understand the Prim's algorithm using this table also, right? That we already discussed. . Now, this is the Prim's algorithm, right? Where G is the graph with n nodes and a vertices, right? And the length of length is a minus r plus, right? T is initially null, b is an arbitrary number of n, right? While b not equals to n. It means while b is not equals to number of nodes, right? Then find e is equals to uv of minimum length or weight such that u is a subset of v and v is a subset of n, right? So this is the selection of minimum weight vertices, right, of b, right? Then add that value of e into t, right, and add the value of that particular vertex into b, right, and return t, right? So this is the Prim's algorithm, right? Now tell me what is the difference between Prim's algorithm and Kruskal's algorithm? What is the difference between Prim's algorithm and Kruskal's algorithm?
In crystals, we select vertices, and in prims, we select
But why we
nodes.
select vertices and why we select nodes? What is the main concept of Kruskal's algorithm and Prim's algorithm?
To generate minimum spanning tree.
Huh. Right now, to generate a minimum spanning tree in in Prim's algorithm, right, we select the adjacent edges only. We select the adjacent vertices of already selected vertices, right? But in Kruskal's algorithm, right, we cannot select the adjacent vertices of already selected it is not necessary to select the adjacent vertices of already selected vertices, right? But we have to select the vertices which have the minimum weight in the given graph, and for both the algorithm we have to consider select the vertices in such a way, right, then it will not create a cycle, right? If it is create a cycle, then this is not the spanning tree because spanning tree does not contain any cycle, right? So this is about the minimum spanning tree using Prim's algorithm and Kruskal's algorithm, right? Now anybody has any doubt in Prim's algorithm and Kruskal's algorithm?
No, ma'am.
No, ma'am.
Right, because both the algorithm have many minor difference between the method, right? Because at the end they both give us minimum spanning tree, right? Just you have to remember which age you have to consider in Prim's algorithm and in Kruskal's algorithm, right? In Kruskal's algorithm never it is not compulsory that adjacent vertices, right? We can select any vertices which have minimum weight, right? So this is about Kruskal's algorithm and Prim's algorithm, right? In next lecture, we start with the new topic. Okay. One more thing.